Thank you very much. So today we're talking about testing. We're talking about testing ETL pipelines. So this is me. My name's Elliott. I'm a data engineer. I've been working testing things for quite a while. I love unit testing, integration testing, and I think it definitely helps because I believe that automated testing for me really is the cornerstone of modern data engineering. You know, you can't write code without testing that it works. You can't deploy code without testing that your deployment's been successful. And, you know, as you process data, you need to validate that your data that you've got meets your expectations. You need to test that. And so if we're going to have all these tests, if we're going to spend time testing things, then, you know, we may as well automate them and make that work for us. And there's two key points really. First of all, when we talk about data pipelines, when we talk about ETL or even ELT, but we talk about data pipelines, you know, we're going to get some data, we're going to try and process it. And if things go wrong, before we start pointing our fingers upstream and going, do you know what, you've made a mistake, you've sent us some rubbish data, we need to be confident that our own code works correctly. If we haven't got that confidence in our own code, then we lack the ability to be able to find issues quickly. And then the second thing is, it's going to happen at some point. It's not a matter of if, but it's a matter of when changes are going to happen upstream to your data sources, which means that your pipelines are going to break. And if you have this mindset of it's a matter of when and not a matter of if, then we can build in the facility to quickly identify issues, quickly diagnose that A, that something's gone wrong, B, we can find out what that issue is. Then once we know we need to fix our code, once we know we need to make a change, we can quickly write some code, write some tests, get the code tested, get the code pushed out to production, and get the pipeline running again. Now, where you have to have a manual testing process, isn't that? And where you have to have QA engineers, maybe taking like hours or days, weeks, sometimes even months to test changes. You know, it's not an efficient way to get fixes out to production quickly. And where you sort of take this other route of just trying to rush changes out and not testing them properly, then what you end up with is often more issues that you then have to fix later on. So you end up with more problems down the line. So this is why, for me, automated testing really is a cornerstone of sort of modern data engineering, of being able to quickly identify issues, quickly get changes back out into production. And it's really key. So when we talk about testing, so what types of tests are there? So we start off with unit tests. Unit tests are small tests that test one piece of code, one thing does one thing well. An integration test talks about an integration test that maybe one process works through an application. So when we talk about data pipelines, maybe one file or one entity can be processed through. Acceptance tests are where we start to be able to show the business that actually, you know, this thing we've built works. This is the set of business requirements, and these are the tests that show that the business requirements have been met. Then data quality tests are where when we process a data pipeline, when we process some data, we put some checks in to say, you know, we believe the data should conform to these standards. Does it actually meet them? And you can do that for each and every file, each and every bit of data you process. And then we have production tests. And now this is where the controversy starts. People go, you know, you can't test in production. And I'm going to try and draw a slight distinction between testing in production and testing on production. So testing on production is where you go, right, we've got some code, we've got nowhere else we can really test it. Let's just go and shove it into production. Let's go and run some queries on production and see what happens. All right, that's the bad testing and production. So that's not what we advocate, and that is the bad way of doing things. The better way of doing things is testing our code in production. So we've got some data quality checks as the code runs through. We've got monitoring to say when things have gone wrong, and we may be able to do things like have sort of parallel runs of the same entity with the new version of the code and the old version of the code, so the business can see the new data working, and then they can flip over. There's things like that, like staged rollouts that we can look at. You have to be careful when you talk about testing in production. I remember I was in a meeting, it was quite a testy meeting with a solution architect, and at the end of the meeting he just sort of sort of threw his hands up in the air and went, well, I guess you're just going to test in production as well, aren't you? And I was being a bit flippant, and I hadn't explained the sort of nuance I've got between testing in production, testing on production. I said, of course we're going to test in production. That's what idiot wouldn't test in production? That didn't go down too well, and I sort of I probably should have explained the nuance of it first of all. But testing in production is a good thing. Testing on production, where you just jump on and do stuff, is a bad thing. So when we look at the different types of tests, and I use a sort of terminology of unit tests and integration tests, and unit test really means, you know, we're going to test one thing. We're going to test one part of a code. You know, for unit tests, we might be testing one line of code. We might be testing a task in SSIS or one activity in ADF. And the complexity of that needs to be really simple. It needs to be really easy to write to maintain those tests. But the confidence that it gives us that anything's going to work in production is very, very low. Unit tests aren't to give us the confidence that something's going to work in production. The only time that we're 100% confident that something's going to work in production is when it's been running in production and we've got monitoring that tells us it's been running in production, it's been working. So we just need to have this idea of sort of on the left, we've got small, quick unit tests, and as we move over to the right, the tests become a lot more complex, but they give us a lot more confidence. And that's quite a critical point to understand. And in a similar vein, as well as being unit tests, integration tests, not having much data, they should be quick to run, going all the way to acceptance tests, which probably take quite a long time to run. Maybe you've got an overnight batch process that runs. And then obviously in production, you've got a full data set. So the idea is that we've got a set of smaller tests that are a lot simpler, a lot quicker to run. And then as we go further on the right, to get more confidence, we start to use more data, bigger volumes of data, and things take a lot longer. Maybe we have like a full scaled up environment. So with unit tests, this is I'm not sure if the picture comes across that well, but it's a big fat zero. It gives us 0% confidence that anything's going to work in production. So it's not going to tell us whether anything is going to work in production. A unit test isn't going to tell us whether any of the business requirements are met. And the unit test isn't going to tell us whether the pipeline or the code has any redeeming qualities at all. All right, that's fine. We've got other tests for those. So what is the point of unit tests? So what does it give us? Well, the first of all is that it gives us documentation. And this is really key. So I worked on a project, it was going back quite a while ago, it's about 4 or 5 years ago now. And the project itself was to bring some data in. It was a regulatory project that had a specific end date. We couldn't be late. Like the EU went to the UK government and said, you must deliver this by this time. So it wasn't a project where we could just split the dates and not worry about it. And so the project itself, it was a set of rules. So we had a data set and then we had to apply a set of rules to the data set. And knowing that we had a fixed deadline, we had to be quite quick in how we worked. And one of the issues was the rules were described in in an Excel spreadsheet. And it was literally rule number 1, check this column meets these requirements. Rule number 2, check these column meets these requirements. And one of the problems we had is that the business analysts would keep changing the rules about. They keep switching the rules from one. They'd make rule number 1, make rule number 76, make rule number 46, number 56. And so what would happen was that the Excel spreadsheet where the analysts were managing what the rules did and the code didn't always match up. So the analysts would come to the developers and they could just say, okay, developers, just who's free at the time? And any developer could say, yeah, I'm free. And they'd say, right, this rule, what do you think it does? And so what we had is a set of unit tests for each rule. So we said, for example, there's a rule to check whether a postcode, a UK postcode was valid. So we had a test that said postcode isn't too short, postcode isn't too long, postcode matches this pattern. And so the analyst could speak to the developers and say, right, what does the code do? The developers could look at the code and they can say, right, we've got a test that says it's not too short, it's not too long. And by too short, we mean 6 characters. By too long, we mean 7 characters. And this is the pattern that we think it matches. And then so the analyst could really, they could keep the spreadsheet and this our understanding in check. And it meant that we weren't spending a lot of time having to rework what we did and go back and say, well, actually, what code, and without actually having to dig into like sometimes some quite long, complicated queries, they could just look at the unit test and say, this is what we believe the code does. So documentation really shouldn't be overlooked. It's really quite important. But what it documents actually is it documents the developer's understanding of the code and the developer's understanding of the requirements. So if you've got this postcode validator checks with a certain length of characters, if you write a unit test that says the postcode length should be 9 million characters long, right? It's obviously wrong, but then if in the code you've also got to check for whether the postcode is 9 million characters, then when people look back at it later on, even though if that developer's not there, anyone can have a look at it. They can say, well, okay, the issue here is there is a bug, and the bug is because the developer didn't understand the requirements correctly, or maybe was given the wrong requirements. So it really cuts to the nub of the issue. If you can just say, right, the issue is there's a problem with the requirements and developer understanding. Let's change that. We can change the test, we can change the code, and we can move on with our lives, rather than having to dig in and go, right, why was the length set to 9 million characters? Was this something I'm missing? Was there something else? So it's a real way to document how the code works and to understand what's going on in the mind of the developer when he wrote the test. And that's invaluable, and that's an invaluable history. You don't get with source control, you don't get with anything else. So it's a really good way to manage the larger coded projects over time. Now, what else unit tests give you is they give you a living example of how each piece of code works. You've got a store procedure and it takes, say, 2 or 3 parameters. You're going to end up with a set of tests which tests that procedure with all the different combinations of the parameters. So you've got, without having to think, right, what do I need to do to pass this store procedure? You've got a set of living examples. So that's another thing that's critical, especially on more complex systems, and maybe you don't know how different procedures or functions are called in different places, or different packages are called in different places. You can have a look at how the tests run the code themselves. So that's good. Now, with unit tests, one of the things we don't need really any data. And when we talk about ETL pipelines, it sounds a bit strange to say, how can you test a data pipeline without any data? And what we do for unit tests is we set up the data we need for each test, and it should be like 1 or 2 rows of lines of code. 1 or 2 rows of data. It's not very many. So you don't unit test with a lot of data, and I'll come back to this later, but it's quite important. So what does a unit test look like? So from our example before, we were talking about a postcode validator. We'll potentially, say if we've got a function in SQL or a store procedure and it checks the postcode, then we've got a set of unit tests which are very specific. We're going to have one unit test that checks whether the length is correct. One that tests whether the first two digits, I suppose, are characters, and then whether you've got 2 or 3 numbers, whether you've got other characters, and also whether you've got things that shouldn't happen. So as well as things that are correct, you look at things that are wrong, like, we haven't got negative numbers. So if you've got a negative number in the postcode, the UK postcode, then it's not valid, it's invalid. So unit tests have to be very specific, and this is why we don't want to test with lots of data for unit tests, because if each unit test has to run with like 10 million rows, it's going to be very slow to run. So as I say, for each unit test, for testing whether the length is correct, you probably need two rows of data, 1 postcode that's the length is correct and 1 postcode that length isn't correct, and that should be enough for it. That's what a unit test sort of looks like. If you're writing unit tests for SQL Server, so if in part of our ETL pipeline we're running some store procedures, the only real choice for a unit test framework is T-SQL-T. T is you can take a table and you can call what's called fake table on it. It generates a completely brand new table without any constraints on. So if you imagine you've got a table that's got 50 columns, 20 of those columns have got non-null constraints, maybe you've got a couple of foreign key constraints on it. What the issue is, if you want to, so say you've got a postcode validator that checks one column on that table. So without T-SQL-T, you've got to insert a row and that's got data in all of the non-null columns. You've got to insert data into all the parent foreign key tables. So before you even start, maybe you only need data in one column, but before you start, you've got to insert data into like 20, 30 columns you don't even need for each test, which A, gets boring very, very quickly. And two, it doesn't really help you think about the code you're calling. When you're setting up your tests, if you only need data in 2 columns, then you think up front what do you actually need, and it helps sort of guide your test writing and helps guide your process to developing really. So if you're writing unit tests and your code is in T-SQL, then have a look at T-SQL-T, because it's going to make setting up data for tests a lot quicker, and it's a lot faster. So when we talk about code, types of code, especially in data pipelines, there's 2 types of code we're really talking about. We talk about the business logic, and so the business logic is how to create a specific measure, a specific value. How do we do that? It's the which entities do we need to load, which data types do we have for each entity, is that sort of thing. That's the sort of the business logic that's critical. And then we've got more of the infrastructure code. Now nowadays this could be seen as, you know, infrastructure as code. So it could be like your ARM templates in Azure. But what I'm talking about here is about it's the code for SSIS that says like go and read from this network share. Let's go and read from this a file from this network share, write a file here, or write to SQL. The infrastructure code is the code that sort of does stuff. It's like the generic code that's in that is exactly the same in every organization, and it's the business logic that's the key differentiator and the thing that changes everywhere. So when we look at code and how to test stuff, we need to, in our minds, differentiate business logic from infrastructure code. So if you look at your existing pipelines, and it might be in SSIS, it may be in ADF, it could be in anything, say MuleSoft, it really doesn't matter. There's 2 typical ways to create ETL pipelines, either with like a GUI tool, and it's like SSIS, or there's to use code. So if you use SSIS, you can create your packages using nothing but tasks in SSIS, and inside your tasks, you might have a SQL task. You can embed SQL text. You might have some C# script code where you embed C# code. If you have this type of pipeline where everything's in the GUI, everything's managed by tasks, it's very, very hard to unit test. If you've got a complex flow to get down to a specific data flow in SSIS, then disabling everything else, you can just test that part, or getting to the point where you've tested that often means setting up lots of data and running lots of other things. So if you've got this kind of like everything munged into one blob of XML, then it's very hard to unit test. So maybe unit testing isn't quite right for you, and it isn't quite right for this. But if you've done things like you bring data into a staging table in SQL, and then you call a store procedure, which brings the data across, and that's where your business logic is, then you can unit test the business logic, and you can separate it. So if possible, what you should really do is try to have this idea of having your code somewhere where you can unit test it, be it in SQL Server, be it in Python, be it in somewhere. Favor writing your business logic there, and then your infrastructure code. If you use a tool like SSIS, keep your infrastructure code in SSIS. You can call it separately. You don't always get the choice of what you do. Some of us have got legacy pipelines which have been running for a long time, and we can't just suddenly pick them up and change them completely. But if you're starting on a new project, on a new set of pipelines, definitely think about instead of just putting all your code into one place and sort of managing it in that XML that everyone loves an SSIS. Think about how you can separate that code to somewhere else to then allow unit testing later on. And this is where, if we separate the logic, it helps us write unit tests, and it helps us with other things as well, like code reviews. If we have our business logic in Python or C# or SQL, then you can code review that. If you've got blobs of XML for DTExec files, or you've got blobs of JSON for ADFs, it's very hard to code review and actually find issues, rather than we're changing something, that looks about right. It was only this morning I was looking on Hacker News, and someone posted about GUI tools for ETL, and one of the biggest complaints was, it's really hard to source control them, especially the SSIS, where every time you build the package, it changes the DTSS ID, and I think they made it slightly better in recent versions, where if you move a box slightly, it changes the XML. I think they've made that slightly better in later versions, but it's still the point still stands. It's very hard to do code reviews and stuff like that. And generally, developer frustration levels. As a developer, I want to use things like IntelliSense. I want to use things like refactoring support in the whatever environment I'm using. And where you've got a little box, a SQL task in SSIS, where you type in a free string that's got your SQL code in, it's not a very good developer experience. It's a lot nicer having that code somewhere separately, which you can write it. So unit tests, so the key points really for unit tests is generally, you shouldn't be, for each test, you should be setting up less than 10 rows. It's not in every single case, and take it on a case-by-case basis. Maybe you need 100 rows or 1,000 rows, but generally, if you're thinking about unit testing certainly with full mirrors of production or cut down data sets for production, then I'd probably stop and revisit exactly what you're doing and go back and say, actually, what do we actually need for each test to prove that each test is correct? The developer's understanding of the requirements are documented if you have a full set of unit tests, and that's really good. They're allowed to do things like refactoring. So this project I was talking about, where we had a spreadsheet, when they wanted to change the rule numbers, our store procedures were literally called rule 1, rule 2, rule 3. And so we could rename everything and still have a high confidence that we haven't broken anything. So that was quite key, really. But really, you've got low confidence that anything's going to work in production. You can have 10 million unit tests, and the chances of it still of anything working in production are very, very small. I'd say 0, unless you've got other tests. So that's unit tests. So we'll move on to integration tests. So these are a great starting point for writing if you've got no tests at all. If you've got no tests at all, I'd start with integration tests. And what these are starting to test that a process works through an application. If you think of a web application, you might have an integration test to say, can a user log in? Can a user print out something? Can a user log out? It's that sort of thing. For data pipelines, it's can a file be picked up and processed correctly, and within that file, do we get all of the columns that we expect in the format that we expect? Integration tests, they are really the way to explain it is you write some data, you execute your process, and then you read some data at the end, right? And that's the same for any integration test for any data pipeline. That's what you're doing. You're setting up some data, you're executing your pipeline, and then you're verifying your data. And that's the same for ADF, for SSIS, for MuleSoft, for any sort of ETL or ELT you're doing. This is exactly the same. So how do you set up your data? There's hundreds of ways to set up your data. So whatever tool you're using, there'll be a way to set up your data. If you're using SQL, you go to your source, you go to your destination, you delete your data, you insert some known values. If you're doing it with PowerShell, it's exactly the same. You just have a command to delete your data. You can do it with SSIS even. Delete your data, delete your data in your source, your destination, set up and create some more setup data. One thing that I would avoid is using backup files for integration tests. To two reasons really. First of all is because if you want to change what's in that backup, you've got to restore it somewhere, change the data and take another backup. And the backup's quite hard to store in source control, so you've got to store it on a file share or something like that, or blob storage account somewhere. So that's a bit of a pain, so I wouldn't do that. And second of all, it's normally like a sort of a code smell that people are testing just with everything that's in production. And the problem with just taking what's in production, taking a copy of that and using that for your data pipelines is because everything that's in production has already worked and succeeded, but you should be thinking about what else could happen, what things could go wrong with it, what things shouldn't we do. So it's normally a smell that people are just sort of thinking everything's good, but actually you should be thinking more about what things can go wrong when you set up your data. Sometimes, you know, you have projects which are harder than other projects. So I worked on one project where we weren't really writing integration tests because it was too hard to set up the data. So what would happen is you'd have to create a set of rows which had random GUIDs in them, and then you had to create data in a whole set of child tables as well. And each test you wanted was slightly different. And as a team, we weren't being effective at writing tests because it was too onerous. And to be honest, nobody could really be bothered to do it. So it wasn't possible just to write some SQL scripts or write some PowerShell scripts to set up some data. So what I did is I used C# to write some classes to manage creating test data. And it did take a couple of days. But what it meant is that we could use this library and say, right, I want to write a test. I want to have 500 rows that look something like this. Give me the data and go and set it all up with all the child tables in the right places. And so what that meant was then we could then start writing tests for it. And that's the only time I've ever really had to create this sort of framework. It was a very specific problem. So we don't always need to do it, but in some cases we do. So if you do get issues, just think about how you can make life easier for your developers as you need to. So we've got some data, we've set it up, and we may have set it up by writing using SQL, like SQL CMD or PowerShell, however it is. I know Rob talked on the last session about notebooks. He would advocate PowerShell 100%, and I think most SQL DBAs are looking at PowerShell more and more. So PowerShell is probably the way to do it. Now we can move on to the next phase. We've got our data set up. We need to then execute something. Right, so we need to execute our process. So if it's DTExec, SSIS, we need to run DTExec, you know, and we can do that just using command line. We can do that using C#. You know, we can do that using a mixture of C# and DTExec. This is, I'm not sure why, but I always end up using this sort of process of using C# to shell out to DTExec. One thing that you find if you use this method, that the parameters you need to pass to DTExec are horrendous to write. The amount of backslashes and quotes you need is one of the hardest problems I've ever found in computers so far. So if you do go down this route, be prepared for at least a couple of hours, maybe a day of working out how to pass the correct parameters across to it. But whatever we do, you know, we execute the process. And then when we've executed the process, we then move on to the next phase, which is verifying that everything's worked. And there's two things we need to do. First of all, we need to check any logging, and then we need to check the data in our destination. So when we've set up our data, we clear down the destination, we clear down the source, and we insert the data that we know we're going to need. And it might be that we insert data into the source and the destination if we want to change data, or it might be just we want to clear out all the data. But then after we've executed the process, we then go and check the data in the destination. And these two key points are key. And checking the logging, what that involves is making sure that as we write our ETL processes, we're putting out into the logging the decisions we've made and enough information that someone can sort of trace back actually. So what happened in this pipeline? You know, we expected to get 10 million rows, we've only got 5 rows. Let's look at the logging to work it out rather than having to trawl through, find files that they can get and reprocess manually. We want to put into login enough information that we can debug stuff, and having enough information that you can tell whether integration tests have worked or failed is a good start to then being able to test things later on. We also need to be very explicit about what it is we test for. So if we run a package, we shouldn't just look to make sure that the word failed doesn't exist. We should be looking for a message that says success. If we know that the package should have written 20 rows, we should look for a message that says the package has written 20 rows. And we can either use the built-in login for that or add our own login to it. But we have to be explicit about what it is we're looking for. It's like if you have it's like you have alerts to tell you whether a server's gone down. Then if you never have an alert to tell you that your alert's not working, maybe the alert's just not working and the server's gone down. You've got to be explicit about what it is you're looking for. So when we validate stuff, you can validate it with SQL. You do a count star for a table, you can check some other things, check whatever. And it's the same with setting up your data and executing your data and verifying it. Just use whatever it is you're comfortable with. If you're using PowerShell to do it in PowerShell. If you're not comfortable with PowerShell, but you're comfortable with Python, use Python to do it. And I typically use the same, like if you can, use the same language that you're using for the rest of your code. So if it's something like SSIS, you're probably going to have to use something like C# or PowerShell to drive the tests. But if you're writing your pipelines in Python, then you can use Python to do the setup and the execution and the verification. So when we start to look at other things like ADF. ADF is going to be ADF integration testing, very similar to SSIS integration testing, except we're probably more likely to be writing files, deleting files than deleting data. And we're also more likely to be looking at file contents rather than the database contents. It's just more likely that we're going to like a data lake or something like that. And when we're doing that, we're probably going to end up dealing with file types like Parquets or Avros, which aren't that easy to write. So you need to have a think about how you're going to write create your test data. Maybe you do have a set of files which you have created already and you just copy into place and run them through rather than creating data each time. Things like Parquet and Avros, you're going to probably need to use something like PySpark to read and write those files. I know there are some C# drivers for Parquet, but I've always struggled with it. So for ADF integration testing, we're probably going to have to start thinking about how to test other things and bringing in other languages to that, like Python. Executing ADF packages is very similar to SSIS. There's PowerShell commandlets. We run a pipeline and then we're going to want to wait for that pipeline to finish. We sit in a loop waiting for it to finish, and this is the same as for any ETL pipeline that we want to run. We kick off a process, and either we wait for that process to finish, or we need to keep polling to see when that process is finished. ADF is one of these things where we have to sit and wait and poll. When you poll, you're going to put a sleep in. And you need to find some sort of balance between what's an annoyingly long time to wait between the sleep and also being wasteful. So you don't want to sleep for like 1 second. You don't want to sleep for like 5 minutes because you'll end up sleeping forever. So you've got to sort of find some sort of balance. But the key really is, run the pipeline, wait for it to finish, and then you can move on and check the output. Now, there's with integration tests, I like to include 2 different categories as well, sort of performance and security. So if your ETL pipeline is processing a load of data, and this data then, is going to contain PII data, and if the data escapes somehow, then you're going to get a sort of 20 million euro fine for GDPR data. Then you're probably going to want to have a think about security, and you're probably going to want to write some tests about security, maybe like checking permissions, checking access to data. But it depends on what data you've got, and it depends on your particular domain and scenario. For performance, I worked in a team, and it was what we were writing was basically a proxy for SQL Server. and it had to be fast. Like the key goals really were the first goal of it was just it was fast. That was the most important metric. Nothing else really mattered. Like obviously like had to be correct, but it had to be correct and fast. And what the development team were finding was things like they were running a whole load of queries through this product, and every now and then a SQL patch would come out or the server would get upgraded, and it would make the nightly build, the performance tests that were running nightly, they would change. Either they'll get better or get worse, but nobody really expected them to get better or worse, and they weren't getting better or worse because of the code that they're writing. So what they did is they took the approach of every day, every night, they took the last 10 days worth of code. They stored the last 10 days worth of code, and then they span up the service, ran all the queries through it, then stopped it, and then took the next day's code, span it up, put the code through it, and timed it. So then what they could do is they could look at charts to say, these are the performance over the last 10 days of each specific build. So if there is something like a patch or hardware upgrade or hardware downgrade, then that would be irrelevant, because they'd see with the same code, they can see whether they've introduced performance issues or made things better or worse. But that was very specific for what they were doing. If you've got a specific scenario, you sometimes have to think about it and think, right, do we need to do more work to add in tests for it? Or typically you don't, but there are some cases where you need to add these things in. If you've got an ETL pipeline, a data pipeline, and it has to finish within 20 seconds or the business is going to collapse, then put some specialist tests in to check that any code changes you make haven't badly affected performance. It's quite critical. If it's critical, put it in. If it's not, don't worry about it so much. So integration tests, the key points really are with the data. With unit tests, we're talking about 1 to 100, about 1 to 10 rows. Sorry. With integration tests, we should start to be thinking about a little bit more data, so maybe up to about 1,000 rows. With integration tests, any ETL tool that's got either a command line or an API is testable. I once had I'd say unfortunate experience of having to work with SAS data flux, which is very similar to SSIS, and it's a GUI tool. But so you typically, as part of an integration test, you can't have someone go to a server, click play, and run a pipeline. But the tool did have an API, so we were able to use that API to deploy the code before we run the test, and then check the code at the end. So if it's got a command line, so DTExec for SSIS, or the Powershell commandlets for ADF, or this API for data flux, then it is completely testable, and you will be able to test it. You may find things like if you have Alteryx, you might have to have a server license to be able to run the tests, and then it becomes a business decision of we can write tests for it, but there is an associated cost because we need to run it outside the GUI, and that's something that you need to take as part of the business. It's a business decision to make. And for an integration test, we're making sure that one process works all the way through. So can we pick up this file? Can we process it? Does it, when it goes to its destination, does it have the same amount of rows that we expect? Does it have the same values we expect? And that's how you write it.
It would seem we are now missing a presenter. Somebody might have stepped on or tripped over a cable somewhere. Hopefully Ed will find his way back.
Ed, where are you?
This is very unfortunate. We have misplaced our last presenter. And he's very much replaced now, or misplaced now, because he fell off the internet.
Oh, wow. Let me check if he's among the attendees. No.
Where in the world is Ed Elliott? That is a very, very good question, Dwayne. We don't know.
It was a very dramatic Brexit recreation or reenactment. That's my
makes
best
a lot of
theory
sense.
anyway.
And there he is. So Brexit was not as bad. And Ed, you're still muted.
Hello, hello, hello. Right.
So you did not try to reenact Brexit?
Tried not to. I don't know what happened there. Suddenly, it just everything went. So
Yeah.
right.
You're not sharing your screen anymore either.
Let me share this. Right.
And he's back.
Okay. Right. So I don't know where I got to. Probably about 2 minutes in. So let me just go right the way back to the beginning and start again. Acceptance tests. So acceptance tests are more likely, you've got realistic data, you've got something the business can get really excited about. Acceptance tests show where unit tests and integration tests are for developers. They show us, how our code works. They're good for us. We like unit and integration tests. Acceptance tests start to show that a business process works. You probably start to see dashboards that the businesses can connect to and say, yep, you know what, they're the numbers I'm expecting. That's what I like. Now, unit tests and integration tests are for developers. Acceptance tests and production are for business users. Every single time I've demonstrated in a sprint demo, unit tests and integration tests, business users go, yeah, great, really, really useful. Yeah, we love it. Yeah, blah, 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 blah. Couldn't care one jot. Couldn't care, take a slightest bit of interest. When you start showing acceptance testing and you start to show dashboards, and that is when business users really come to life. You'll probably even get suggestions of colors to change. Tweak this, instead of making it a square, make it a circle and this sort of thing. It's acceptance tests are where business users get really excited. I prefer to demo things on the left because you're normally left alone to get on with it a little bit more. So acceptance tests are where we've got probably a full suite of integration tests that run. We've got all our data pipelines. They actually run end to end. Maybe they run on a nightly basis. Maybe they run more often. Maybe they run less often. And you've probably got all of your data in there. So acceptance tests, UAT. I've heard people call it QAT, different environments. It probably is a mirror of production to some extent. Especially now we're in the cloud. If you want to have a SQL data warehouse, it's the same as production for a couple of hours. You can do that. It's just a business decision about cost. So when we look at sort of types of code and how we test them, so we've got like business logic. So the business logic, if we can pull it out of packages and have it into some code, then we can write unit tests for it. If we can't, then we can only write integration tests for it. And this is where we set up data, we run a process, we verify the data. And we can also have acceptance tests for it. So, business can have a look at dashboards that show data actually coming through all the way through the pipeline, and they can see dashboards and they can see the numbers and they can validate those numbers and say, yeah, you know what, these numbers are exactly what it is we thought we wanted. With the infrastructure we code, we can't have unit tests for infrastructure code really. So we look at writing integration tests and acceptance tests for it. So what I wanted to show you this is really how we start to use different tests to do different things and to look at the whole testing landscape of, we have unit tests where we can, we have integration tests for processes, and we have acceptance tests to show that everything actually is working. So remember on the chart at the beginning, we've got unit tests give us very low confidence that anything's going to work in production. Acceptance tests, we're pretty close to saying that, it's going to work. Now, no matter how extensive your acceptance testing is and your UAT environment,
It would seem that Brexit is still an issue.
Yeah, that's tricky.
It is kind of exciting to see if he's going to come back, though.
crossing our, what's the expression?
Keeping our fingers crossed.
Yeah, crossing our fingers for the English.
Yeah.
Come on,
Maybe
Ed, you
someone
can
is
do it.
running around his yard with a shovel, trying to kill his internet.
Yeah. Like
So
neighbors had enough of him
the
hogging
question
all
that
the.
I ask is, did he do any unit testing on his internet connection?
That would be a fair question to ask. And how do you test?
Yeah,
I mean,
because
if you're
obviously
looking
he's
for
now testing in production.
Right. And you would have to define a success metric as opposed to just a failure metric.
Mm-hmm.
Yeah,
I think
that's pretty much what I picked up.
I think you and I could do a really hack job of this session.
Alex Yates says, surely that would be an acceptance test. Yeah.
Well, that's also a good
Okay,
point.
and Matt's saying, must have been a co-video issue. Oh no,
Oh.
we're going down that route.
You did not just. This is why we can't have nice things.
Where in the world is Ed Elliott? Hashtag too soon.
So I've seen Enrico van der Laar create an AI that did where is Waldo. Maybe we can have him change that a bit to answer the question, where is Ed? Where in the world is Ed Elliott?
Yeah.
London
the
might
same
be
guy
the
who
truth,
did-
yeah.
Was Enrico the same guy who did the session on the AI to create like the ultimate metal song?
Crazy
Is
data
that the same
science,
set?
that's the guy. He is not sane in any way, shape, or form. But then again, he's Dutch. So
Certifiably, yeah. And a metal fan. I mean, so
sure,
I guess Dutch metal fans or yeah.
special.
I can still see Ed as online in the participant list.
Yeah, the fact that his presentation is still on is kind of
Oh,
confusing.
hopeful. Do you think he took a bio break just?
Speaking of which,
Oh, we
and he's
lost
gone.
him.
Yeah,
So maybe he'll be back in a couple of seconds. He's just trying to reconnect perhaps.
or an hour. That works.
I could make Brexit jokes all day.
I think I could too. Or we could take over the session. That would be different.
Yeah, thing is, if my clients saw me talking about how I really view testing, I don't think I'd have that many clients left. So maybe not on second thought.
You do know that this is recorded, right?
Oh, no. Bye.
You
Yeah.
should know better than this,
Yeah,
Daniel.
my clients don't look on YouTube. I think at least they would have told me.
So they
Alex
mostly work
Yates
with
says,
stone tablets.
Alexandra, Sorry?
They mostly work with stone tablets and stuff.
I wouldn't go so far. I'm gonna stop talking about my clients now. Alex Yates actually says, Alexandra, I love your webcam with the faded background. What is your setup? So this came up earlier.
Yeah, so the reason that the background is very faded is due to the lens that I have on my DSLR. So the lens is what's known as a fast lens. It has a very shallow depth of field. It's an f1.4 lens, a Sigma one, 16 millimeters. So that's why I'm in focus and that is not. But it's pretty quick. So it can, as soon as it realizes that I'm pointing at it, it does that. So yeah, it's nice.
The issue I have when I'm a photo enthusiast, anything below say f2, and it's never really sharp. It's never really sharp because you can never autofocus or focus on the correct spot. I obviously haven't tried it for webcams and autofocus, but.
Now that's a very good point, and that's why I've stopped this one up to 1.6, which is one step. It is noticeably sharper at one step than it is full open. And since it has software to do face tracking, it's pretty darn good at keeping my mug in focus. So I'm super happy with it. And yes, Alex, I'm using a DSLR as a webcam because I do a lot of training stuff over the internet. So I decided to opt for a slightly better
Your thing.
visage. And it's not just because I think I look good. It's let's leave that conversation. Stop smiling, Daniel.
No, I would totally too if I could afford it, or if I put the money into it.
Now you're talking.
Yeah.
Thank you,
I mean,
Alex. That
it is
makes all
flattering.
the sense.
You have an outstanding portraiture set up with the soft boxes and the short focus and everything, and yeah.
Yeah. Do you know the only thing that I'm missing?
Hmm?
A
Don't say
really
ring
good
light. Don't.
model.
Bring out your cat.
Now you're talking. I
We're
don't
on the
know where
internet.
she is. She's surprisingly quiet as well, and that's also scary. It's with cats like kids. If it's quiet, danger with
Mhm.
Robinson, danger.
Mhm. You need Kevlar pants.
Huh.
I used to have a cat once, and for some reason or other, I treat animals very well. I love animals. I'm just not a cat person, but this cat, he had it in for me, and he would just attack me and bite me. Like, not playfully, he would really stab me. Yeah. He had a rough background, I guess. So there were other issues going on. It's
Well,
just
that's what
I
we all
don't
tell
trust cats.
ourselves. That's what we all tell ourselves.
Yeah.
But yeah, if you want to think that, go right ahead. So we are absolutely missing Ed.
Yeah. Oh, there he is. He's an attendee. I'm gonna. Oh,
Yes?
you need to promote him.
Where is Ed? Let me fix.
Under
Yep.
attendees, you can filter.
He is now promoted as a panelist.
Right, sorry about that.
Welcome back.
I lost all my internet access. I turned it off. I didn't put enough money in the meter.
We were talking about, did you actually do any unit testing on your internet connection?
I wish I could, but no, I didn't. If I could have, then I would have. Right, so let me start sharing and we'll have another go.
We have been talking about cats and all kinds of weird stuff.
Oh, have you? We haven't got a cat, we've got a dog.
There we go.
Right, so what I was saying, so where was it? So acceptance tests are where users the business starts to get quite excited. This is where they like to see things. It's likely to be a full mirror of production. It's going to be everything that we need to test properly. Now, production. This is where people start to get more nervous. You know, testing in production is a bad thing, but that's testing on production. Testing in production is good. Testing in production is having monitoring. It's having data quality tests. It's saying, okay, we've got a file. We expect it to have these data types. Does it have these data types? We expect to have this column should never be null. Is this column never null? We expect we expect to have at least 10 million euros in sales. Have we got 10 million euros in sales? It's that sort of thing that we can start to add to data quality. Things like phase deployment. So this doesn't always work for data pipelines. It does sometimes. You know, maybe if you're processing files from a number of different systems, maybe you can roll out your code and start using the new code for some of your systems and not all of them. Maybe you've got a test system. You can start looking at, you know, is the data being processed correctly for that before you start rolling it out to everyone. Side-by-side entities. So this is an interesting one where if you version your entities that you bring in, perhaps you can bring in, have your code running twice for the same file, bring it in twice, but with your new code and your old code, and you can show the business, say, look, this is what you're getting with the new code, it is working, and then you can turn off the old one. You can build this sort of side-by-side loading into your pipelines. Now, it's not always possible. Depending on your environment, if you're using things like ADF with SQL DW and Databricks, it's probably more possible, easier to do than legacy things like SSIS. But it is possible to start thinking about, you know, how can we get our code into production and running without actually making it live. You know, people for like websites have things like feature switching. You know, Facebook, they roll out a feature, they don't just turn it on for everybody straight away, they turn it on for sort of groups of users. How can we do this sort of thing with our data? So for data quality, you know, if you're writing to a database, there's no better data quality check than a constraint. You know, if we don't expect nulls in this column, let's put a not null constraint on that column. That's great. It's a great way to validate your data and validate the data is correct. If you're using, so I used to do quite a lot with Databricks and Spark, and so we use Delta Lake on top of Data Lake, which is a bit of a mouthful, but it's a way to get, you know, the traditional ACID properties of a database in a file system in a Data Lake, and Delta Lake is bringing things called expectations later on in the summer, which will allow you to add constraints to files. So say, you know, we're bringing in a file, it's going into the Data Lake. Before it gets written to the Data Lake, does it have the right data types? Does it have not null constraints? That's one way you can do that. One way you can check data quality. Another thing, there's a framework called Great Expectations, which is a Python framework, and I'll show you a demo of that in the next slide, or a screenshot of that in the next slide. And then also, you know, you can write your own checks as you're bringing a file in. If you expect a file not to have nulls or to have data types, validate that is correct as you bring it in, and as you validate it, write out your logging. No, we validated it, it's all good, or we validated it and these are wrong. These ones are wrong. Add that into your logging so you can get to it. This is an example of Great Expectations. So it's a Python framework for testing exactly that, checking your expectations against some data, be that in a file or in a database. You know, you might have table level expectations. Say we expect a minimum number of rows, or we expect to have a minimum number of columns, or the columns must be in this order. Or you can do things like, say, values in this column must never be null, or they must be between these two date ranges, or and the test can get quite complicated. So the more tests you've got, the more complicated you've got, but the more valid you can ensure your data is before either before you start processing or after you process it, to say, you know, we've processed our data and it's still good. There's nothing worse than silently failing errors where you're pushing data through, which is invalid, but then, you know, for 6 months you're showing reports to your CEO, and then after 6 months you realize the data's been wrong for that time, and then having to explain that actually the data's been wrong. It's a critical mistake. So having this ability to apply a set of expectations over your data, this is how it looks like, it really gives a lot of confidence about the data being correct and the correctness of that. That's a really good thing we can do. If you can't do things like using Great Expectations, there are simple things you can do. You know, you can check your row counts, check your averages, check the shape of the data, and these are checks you should be doing for all of your pipelines. And as you bring in, as you release more code, you should know the row counts. If one entity is always about 100,000 rows, you know, it shouldn't suddenly veer off to be 10 million rows or 5 rows. So it's these simpler checks you can add in that actually add a lot of value to your pipeline. And so monitoring really is the key to testing in production. So everything you've got, all your data, so, you know, you've got your data volumes, you've got any errors, you've got successes, you've got timings, you've got facts about your data, like when was the last order date. Every time you process data, take all this information you've got and push it into a single place. So if you're in Azure, Log Analytics is perfect for this. So I put all of my data for everything. So all the infrastructure data, all the data about the processing of when pipelines have run, how much data they process, how much data they read in, how much data they wrote out, any facts we can, just get it all into Log Analytics. It's a great place to store it. If you're not in Azure, you know, you don't have to use Log Analytics. It can be anything. It could be Datadog or Splunk, anything that can take your data and allow you to query it. If you haven't got any budget, but you have got a SQL Server you can use, you know, you can write the data to tables in SQL Server and you can write that there. It's just, the key thing is just putting all your data somewhere where you can get to it in one place. And then once you've got all this data, once you've got it in your monitoring, then you can send out alerts. You know, if you expected to receive a file and you expected to have 10 million rows in it, like normally on last year, it's been 10 million rows. If that veers off and suddenly it's 1 row, set up an alert for that. Have dashboards that you can look at as a team every morning to say, right, these are the pipelines, these are the ones which have been processed, these are errors, successes, this is how much data we process in each pipeline, these are how long they've taken, and you can start to be proactive and say, look, actually, we're starting to get a lot more data, the timings are starting to go up, maybe we need to do something about it. Or if you have a chart that shows your data volumes and suddenly it's dropped off a cliff, then you know there's probably something wrong. I mean, it might be that COVID-19's happened and then no one's buying anything, but at least you can look at it and you can reason about actually, is there something we need to do? And you can be proactive about it rather than waiting for users to shout, there's something not right with my data. So get all your data, get it into one place, get some monitoring, and then set up some dashboards and some alerts over that monitoring. It's critical. And until you see your data that's gone through, it's been released, your code's been released to production, your data's flowing through, at least until you see the actual data on your dashboards that say it's worked correctly, you'll never have 100% confidence that it's actually completed. So while I was disconnected, there's something I was going to say and I forgot, so I'll just say it now because it's quite relevant. So you can have a completely mirrored production that's exactly the same as production. It's got the same scale, it's got the same services, it's got the same number of servers, it's got exactly the same data, but you can never be sure by 100%. You can get close, you get like 99% sure that what works in UAT, in your acceptance test, is going to work in production, because there will always be things like you have a expired server certificate, or you've got a DNS name that's wrong, or there's something critical that's a slight variation that could go wrong in production. So until you've seen via your monitoring that everything's worked, you'll never be 100% confident that everything's worked. So going back to this sort of how to test code, so we've got our business logic, we've got the infrastructure code. So for the data quality we're receiving, you know, that's through data quality checks, through monitoring, alerts and dashboards. For our infrastructure, you know, it's monitoring. If you're writing to a SQL server and the SQL server goes down, then you need to have monitoring that's sending off alerts that's telling you this. So this is how we sort of separate the different bits of code, and we look at the sort of the whole testing landscape, which is, you know, let's write unit tests, let's write integration tests, let's get all our integration tests together and write acceptance tests, let's look at production, let's look at what data we've got, let's make sure we write enough data in production when we're processing our data to be able to go back at any point and say, right, how did we get into the state we got into without having to rerun everything through again. And if you get into the habit of, as you're writing your pipelines, writing enough information for your integration tests and saying, you know, every decision we make, if we've taken a certain path down a certain route with this row of data, let's log why we've done that for this entity. Let's log everything we can about it and get it into somewhere you can monitor it. So where do you start? Right, so you've got ETL pipelines, you've got no tests at all. So the first thing really is start with one test, start with one integration test. You probably maybe never even have unit tests if it's one of those pipelines where the test and the infrastructure code and the business logic all shoved together in one sort of blob of XML. So maybe you'll never have unit tests. But start somewhere. I worked on projects, and it wasn't a data pipeline project. It was a website where the code had been outsourced, and the outsourced developers weren't moving fast enough for the business, so they sacked that set of outsourcers and then they handed the code over to another set of outsourcers. And you can imagine how well the handover went between the two outsourcers. It was sort of pretty much non-existent, and the code was in a pretty bad state, and when it moved across, it just sort of got into a worse and worse state. So eventually the business decided to bring the code back in-house, and they set up a team to bring the code back in-house, and I was part of that team. And the code was just terrible. Everything about everything just didn't work. Like the website went down multiple times a day. Like nobody even knew how many times a day it went down. And so our goal really was to start to rewrite pretty much all of the code and to make it stable. So our first goal really was just to write 100 tests. It doesn't matter what they were. We just said 100 tests. We weren't looking at how much code coverage, whether it's integration tests or unit tests. We were just saying, look, let's just get 100 tests and just see where we go from there. And a lot of the old code, we never actually wrote unit tests for. We didn't. There wasn't a lot of point because we were sort of ripping it out. So we'd write integration tests, work out how the old code worked, what it was meant to do. Then we'd change the code and write unit tests for sort of the new code. So for that, you might not even ever end up with unit tests especially if it's legacy code or if you can't. So where do you start? You start just write one test, get that working, get that included in your build pipeline. So as you check code in, don't do a code review until you know your test passed, even if it's one test. And eventually you'll have one, and then you'll have two, and then you'll have 3 tests. And if you keep doing that, you'll end up with a good suite of tests. It can take a bit of time, but you've got to start somewhere. If you need some further help, so I talk on my blog. I've got a ETL testing link. There's a few articles there on testing, and there's a couple on Python and a couple on SSIS. There's T-SQL-T if you're writing SQL Server tests. If you're in Python, use Great Expectations to validate your data. And then also a couple of links from Martin Fowler, who talks about unit tests and integration tests in more of the sort of traditional sense of like web apps or apps like that. But there's some good links there. I'd recommend reading these and following these. I don't know if anyone's got any questions. I haven't got anything else to say really. I'm done.
There are no questions so far. Now that we know where Elliott is.
Yeah, great. And sorry about the internet going down. I live in a village in Sussex in the sort of English countryside, so it's not always completely reliable, and we can't really go to the office at the moment.
No, I'm sure Jeremy will be quite able to cut and splice and do an excellent session out of this. So no worries at all.
Lovely.
All right, thank you so much for presenting. It's been very enlightening. I didn't know very much about testing. I know much more about testing, and I also know just how little I know about testing. So I'm going to be diving into these links. There is one question though. Are there any available implemented examples of ADB test setup?
ADB test setup.
Dwayne, what do you mean with ADB? Automated database test, maybe? I'm looking in the chat and hoping Dwayne will be writing an explanation. Azure DB, maybe?
Azure DB. So for Azure DB, you can use T-SQL-T, and that's the best way to write unit tests for Azure DB. So with T-SQL-T, you say you have a table, and you want to write. So if you've got a stored procedure that does something to that table, you have a test that says called fake table on that table, and it gives you a new table that's completely empty. You insert the rows that you need, just the columns and the rows you need for that, and then you run your code. And then at the end of the test, the table gets wound back again. So my dog's decided to run in the room and shake her ears loudly.
And it turns out that ADB was not Azure DB, but it was Azure Databricks.
Azure Databricks. So if you're writing Databricks code, then you'll be writing it in a language. So you'll either be using Python or you'll be using Scala or Java. So this goes back to looking at how you write code. So if you have notebooks which do things like use the magic commands to like import another notebook or to do something like that you can't run locally. So if you've got a Python notebook that uses magic commands to do things, then it's quite hard to unit test that. Like really, you can't test like one cell does one thing. So in that case, you can only really integration test where you deploy your notebooks, then you set up some data, and then you run your whole notebook, and you take that as a complete thing. And that's very similar to SSIS. But if you structure your notebooks in that you have like your codes in a Python module which you deploy, and then you call that module to do work, you can unit test and integration test that Python module separately. And so that the goal really is being able to run your code locally on your machine without having to deploy it to Databricks. If you've got notebooks that do things that don't allow you to run it locally, then you have to deploy it, and then you're talking about integration tests.